Hello, hi everyone, it's Sitish here. So today we will start with one particular project called as an data analysis project we're going to do. So welcome to fifth day of my session. Let's today we will do some kind of a data analysis project, okay, which is called as an you can say accelerometer data analysis using the Python. How you can predict the different values and how you can see the graphically how the particular accelerometer is using in our data analysis projects. Okay, these all the things you can easily see it. Now if you see accelerometer, it is a kind of a device. Okay, actually it's a device where it is used to measure the acceleration or the vibrations of motions. The data provided by an accelerometer is a three-dimensional and can be used in some you can say data-driven applications for solving the problems like fall detection or health monitoring. Okay, in this particular fields, this accelerometer we mostly use. So if you want to learn how you can analyze the accelerometer data, so for today session we're going to see that only. For the task of accelerometer, what happened for the data analysis? We first need to collect the data which is collected by an accelerometer. So as an accelerometer collects the three-dimensional data, it is a little bit essential to have some kind of an data about the x, y, and z axis in our data set with respect to any particular time. As you can see in the graph, okay, I have some particular data set with me. I'm going to provide a data set in the link below. You can take the data set from there, and I'll walk through the how you can analyze the accelerometer data using the Python and what are the things we can do. Okay, so let's start. Let's open our Jupyter notebook and directly we're going to go on the hands-on practical. Okay, now let's start our particular session. Okay, now take a one particular notebook, okay, on a separate file, and in that file name that file as in you can say data analysis project. Okay, first of all I have to import the necessary libraries. So let's import the necessary libraries. So in this particular project we're going to use the three major libraries, which is called as an import pandas spd for reading the file, then import Plot.Live. Okay, we're going to use the Plot.Live for our visualization. Okay, so Plot.Live dot express as px. Let's give them some aliases, and at last we have one more data set called as a Plot.Live only. So import Plot.Live dot graph data or graph objects. Let's take this particular module because this module we're going to need for the particular getting the graph, and let's give the aliases. Now run this particular file. Just wait for a little bit seconds. As okay, no errors. Now we can move further. Now we want some data, right? So data equal to pd dot read underscore csv. Now we want some particular data, right? So for that thing we require one data set. So let me upload that data set here, because in order to work with it I should upload the data set first of all. And okay, I'm uploading the data here. You can say acc data dot csv. I've uploaded this. Now let's give the name of the data acc data dot csv, right? Now print this data. Let's see our particular data what do we have. Okay, let's print only 4 to 5 rows, guys. So for that I'm going to use the dot header function. It is going to give me the first 5 rows. You can see date, time, acceleration of x, acceleration of y, acceleration of z. And 3 axes we need. Just I have discussed you. I require the 3 axes in order to deal with the data. Okay, with respect to particular time. Now let's visualize the things. Okay, we're going to visualize line plot only with the time on x-axis and accelerometer data on the y-axis. So for that let's visualize the things. Call as in let's take one variable called as figure and use the px dot line graph. Okay, px dot line graph. Inside that put the data, and just I have said to you on x-axis we're going to put our date, right, and one y-axis we're going to put our that is acceleration of x-axis and acceleration of y and z. All the three particular data I'm going to put. So rather than just always writing things. Let's put our x-axis and y-axis. Okay. Okay, I'm doing the little bit of copy pasting of this column name in order to avoid any kind of incomplicacy further, because sometimes even one single word missing will going to give you a false error. So you can take acceleration of y and acceleration of z, right? So this particular three axis we have taken. Now next, after that, we're going to see the title. Let's give our some title, guys. Title equal to, you can give like yeah, you can give like acceleration, right? Acceleration over data over time, right? Acceleration data over time. So we have created our data. Now let's take dot show. Let's see our particular visualization, how we have created our visualizations. Okay, we should go and get this type of graph which you have seen our practically. You can see this type of graph, we should get it now. Now let's see whether I'm getting this graph or not. Okay, we're going to try the visualization of the data. Whatever we have, all arguments have same length. Length of the y is 3 and the whereas length of the previous process is, it is okay, no worries. We have to check our length, whether our length has been particular acceleration of x. Okay, there should not be any kind of a gap, guys. Remember, this particular gaps and spaces also will going to give you the false errors. Okay, false things. Now let's see. Yeah, everything we have checked it. Now run it again. Just wait for 2 to 3 seconds because it takes time. Plotly library is little bit big libraries and it will take time in order to visualize the things in its own way. Okay. We will wait for around 3 to 5 to 10 seconds depending upon the configuration. You can see now this is my acceleration data over the time. You can see value I have given and data I have given. Value has been there on y-axis and date has been given on x-axis. Now by analyzing this data, if I'll put my particular cursor here, you can see variable equal to acceleration of x, and the date is September 6 and value is my 0.396. So in this way I can able to remember the things. You can say there is a green line and there are violet lines and there are orange lines, right? So you can see acceleration of x-axis is a violet line, acceleration of y-axis is a orange, and acceleration of z-axis is my green line, as I have given this particular type of labeling. You can see, so this is the advantage of using the Plotly library, because it will going to give the this particular legends automatically. Okay, and you can visualize the things. And if you wanted to zoom out, you can zoom out. If you wanted to zoom in, you can do the zoom in. Okay, all the features is available in this Plotly. Next, let's have a look at the average acceleration actually values by the hours of day and the day of the week, which can help us to identify any patterns or trends in the data. Okay, let's see our data. Data by hours, as I'm saying, data by hours equal to pd dot, we're going to convert our daytime pd to date time and convert this data into the time. You can say time. Do check on the spelling mistake, guys. Okay, it is little bit, if you get any one spelling mistake, then it will going to throw the errors. Now dt dot hour. Okay, we have converted our date into hours. Okay, now next we're going to do the particular date. Now we have converted our date. Next we're going to convert our day of week. Okay, data, let's do the day of week. Okay, and this day of week equal to, we're going to convert into pd dot to underscore date time, and this particular date time again the data, and we're going to take on date. Check on the that spaces inside the spaces. Okay, do check on the all the things. dt dot day underscore name. Okay, now next we're going to convert our aggregation data, right? We want aggregation data with us in order to show the acceleration of acceleration of values by hour of day as well as day of the week. We have done the hour of day and day of the week. Now we're going to do the identify the patterns or trends in the data by using the aggregation data. So data dot use the pivot table. Use the pivot table function. You already know pivot table, guys. It will going to summarize my data as we have do the pivot table in Excel. It will going to summarize our data. So index equal to r. Okay, index equal to r, and the columns equal to day of weeks. So let's take columns as day of week. Give that name only which you have given for the variable in this particular variable, this day of week in r. Okay, and at last we're going to take our you can say values. Let's give our values equal to acceleration of x-axis, y-axis, and z-axis. Okay, we're going to see the acceleration of x-axis, y-axis, and z-axis. Let's take this particular acceleration here, and we have to give the aggregation function, I guess, aggregation function. So if you say aggregation function, is we have one particular property named as aggregation function, and here you can give as mean, median, mode, like this. So but in this particular case I'm taking as a mean. Okay, now after doing the aggregation function, let's create our heat map. Okay, we're going to create our heat map. Okay, let's create our heat map. This heat map will going to give us the actually average acceleration by hour of day and week. You already know that our heat map will going to give you the color encoding concept. So where to denote any kind of an particular acceleration or any kind of an aggregation in terms of the encoding concept, then we use the heat maps. Okay, let's visualize for the heat maps. Figure equal to, let's use the go dot heat map, go dot figure. We are using the this particular library. So go dot figure, and inside that figure we're going to use the heat map. Okay, now x equal to, you can say aggregation on data dot columns label. You can take the column labels, and y-axis you can take as aggregation data again, that you can take as an index. Let's see. And the next z-axis you're going to take as again aggregation data and take as values. And let's see, x gap equal to 1 and y gap equal to 1, and color scale, let's choose our color scale. We can choose our like red. Let's choose our color scale as red and blue. Okay, we can choose our color scale as red and blue only. Okay, and at last let's see color bar also. We're going to set our color bar. So these are the some, you can say, heat map properties. Okay, and this heat map properties is to learn the heat map properties in detail, you can connect to Coachx. Now let's see the dictionary and give the as a title equal to, you can give the title, you can say average acceleration, right? Average acceleration we are calculating. So average acceleration, right? Average acceleration, and this average acceleration. Now next we're going to set our update. Now fig dot update method, and update layout we're going to set the, let's give the title, as you know, title equal to average acceleration by hour of, okay, by hour of day and week, right? Week. Okay, now let's see our figure. So my figure is visible or not. Fig dot show, and let's see our figures. Now let's see, you can see after listening to this particular figure, now you can say this particular visualization has given me this type of average acceleration by hour of day and week. Okay, and this particular acceleration that on week has given. Now let's create a new feature actually, which is going to represent some magnitude of the acceleration vector. Okay, this is the average acceleration we have created. We have one also called as an you can say magnitude of acceleration over the time. Now average of acceleration over the time, and this particular average of acceleration over the time will going to give me the particular results, and this acceleration will going to, let's see now our acceleration over the time. Now here we're going to create our particular over the time how much magnitude of accelerations we are creating with respect to the acceleration on magnitude. Now if we are creating any kind of an suppose figure, I'm taking figure equal to px dot scatter, and I'm taking the scatter plot as data x equal to time, and y I'm taking as, you can say y equal to, I'm taking as acceleration magnitude, and z I'm taking, or you can say title I'm taking magnitude of acceleration over time. So let's say okay, magnitude of acceleration over the time. Now I'm getting scatter plot. So let's pick dot show. Okay, let's see the scatter plot we are getting. We got our particular, again the spacing issues we have got. So let's create, okay, before the spacing we have to do the data acceleration magnitude. Okay, acceleration magnitude we have to calculate. So let's calculate the acceleration magnitude, and to calculate that magnitude you already know that our particular acceleration of x-axis which we are taking, acceleration of x-axis, and which is the square of the acceleration of x-axis, plus you already know the data of y-axis, right? So simple formula I'm writing in this particular Python, acceleration of y-axis, okay, whole square, right, and plus the data of acceleration of z-axis, right? So acceleration of z-axis, okay, and the whole under root of this whole thing. So under root of whole thing is 1 by 2, that is our 0.5. This magnitude we have calculated, right? We have calculated this particular magnitude. Now let's run this particular magnitude here over the time. After running this, you can see our magnitude has been get calculated. This is our magnitude of acceleration over the time. You can see acceleration magnitude on the y-axis and the time over the this x-axis. So this is the magnitude acceleration. Each dot will represent the different timelines with respect to its magnitude. Can you see? Each dot will going to represent that only. Okay. And at last, we're going to create our you can say scatter plot. This is how we can create our this particular points in the 3D model, where x, y, and z axis are representing the acceleration in each respective direction. This is for the one direction, right? I want this particular representation in the all directions. So for that we're going to create definitely a 3D plot. For that, again I have a method called as an px.scatter, because I am taking the scatter plot only, and create this in 3D. So I require the 3D. Simply you have to add the 3D and take the data and give the x-axis again as acceleration or the x-axis, and y you can give as acceleration of y, okay, and z you can give as acceleration of z, okay, acceleration of z, and give the title as acceleration in 3D space, right? Acceleration in 3D space. This much is enough. Just one line of coding is enough. Now last, let's say fig.show, right? In order to show the graph, we're going to use the show method. Fig.show, that's in 3D part or 3D visualization. Now, can you see? I can see the data in all direction, guys. I can see the data in all direction. With respect to any data I wanted to see, I can see. This is my particular data. You can see, guys, here. This is my particular data in 3D visualization way. Okay, how this particular data is represented in a 3D way. Now, let's set to turnable rotation. We can set to the camera. You can take the snapshot of it, and you can take the if you wanted to download this image, you can download this image. But you can see this is my 3D visualization. Okay, acceleration in 3D space. And at last, let's see how the particular histogram is also in order to visualize the distribution of the magnitude of the acceleration, right? So you can use again fig equal to px dot histogram, px dot histogram, and data. Let's take the data. Inside the data, put the x-axis, which is acceleration of magnitude, because we're going to take the magnitude, and we're going to take the beans. Let's take beans as n beans, and this beans I'm going to set as 50. Okay, depending upon the data I have, and give the title. Give the title as give acceleration magnitude histogram. Right, we are taking histogram, so I'm setting histogram. You can take any title you want, it doesn't matter. You can take any title you want. Okay, let's set big dot show. Let's see our histogram also here. Now this particular histogram you can see here, this histogram has been represented in this way, right? So this is how you can analyze and work with the accelerometer data analysis using the Python. You have so many methods, you can create so many visualization with it, and you can represent your particular accelerometer with the help of different types of visualization, like in 3D space. Like see, which I have created this one. Can you see? So I'm creating this one, you can see, right? You can view with any particular directions. Okay, this type of plot you can easily create with it. And as you know, accelerometer is used to measure the acceleration or vibration of a motion. Okay, and whatever the data provided by this particular accelerometer, it is in three-dimensional data, which can be used to data-driven application for solving the problems we have already discussed, like in the fault detection and the health monitoring, this type of concepts. Okay, so to learn this particular data analysis in detail, how you can learn the so many projects and how you can create the projects using the data analysis, you can connect to Coachx.Live. Definitely they are going to guide you at the best level. Okay, so for today, let's call it for today, guys. Yeah, thank you for today. Thank you. Bye bye, everyone.